Welcome to this guide on types of prompting techniques in AI. Today, we'll explore zero-shot, few-shot, role prompting, and more based on key concepts from our comprehensive PDF. Zero-shot prompting gives no examples, relying on the model's pre-existing knowledge, like simply asking to translate hello to Spanish. One-shot prompting provides a single example to guide the model, such as English, hello, Spanish, hola, before asking for another translation. Few-shot prompting takes this further by providing multiple examples to establish a clear pattern, ensuring more consistent and accurate responses. Role prompting assigns a specific persona to the LLM, like act as a marketing expert, or you are a senior software engineer, to guide its responses. This technique activates relevant knowledge domains and response patterns, allowing the model to provide specialized advice, such as analyzing a product launch strategy or identifying security vulnerabilities. Chain of thought, or COT, prompting encourages step-by-step reasoning by breaking down complex problems, leading to improved accuracy and transparency. For instance, when asked, a farmer has 15 sheep, all but 9 die. How many are left? Think step by step. COT guides the model through each logical step to arrive at the correct answer. React prompting combines reasoning with acting, using a thought-action-observation cycle to solve complex tasks, especially those requiring external information. An example is finding the current CEO of Microsoft and their tenure, where the model thinks, performs a search action, observes the results, and then formulates a final answer. RAG, or Retrieval-Augmented Generation, combines retrieval with generation to enhance LLM responses by incorporating relevant information from a knowledge base. The RAG process involves a query input, knowledge retrieval, augmenting the prompt with retrieved context, and finally, an enhanced response, which significantly reduces hallucinations and provides up-to-date information. Safety prompting mitigates risks like harmful content by using techniques such as explicit constraints and output filtering, ensuring responsible AI outputs. An example is a safety-enhanced marketing prompt that includes instructions to ensure inclusivity and avoid stereotypes, balancing functionality with safety. Prompting techniques are highly versatile across various domains. In sales, role prompting can generate targeted pitches, while in engineering, COT helps analyze complex problems. For procurement, RAG can analyze supplier data, and in coding, React can debug by pattern, demonstrating the broad applicability of these methods. The CRISP prompting framework provides a structured approach, encompassing context, role, instructions, specifics, parameters, and format. This framework ensures comprehensive prompts, like creating an email campaign for a new productivity app, by clearly defining each element. The Role Goal Context Constraints framework is similar to CRISP, but more focused on goal-oriented prompting, defining the persona, objective, background, and limitations. An example is guiding a UX designer to create a user journey map for a mobile banking app, specifying the target users and key personas. Tree of Thought, or TOT, prompting allows LLMs to explore multiple reasoning paths like a tree, enabling self-correction and the exploration of alternative solutions. Self-correction prompts enable LLMs to identify and fix their own mistakes, iteratively refining outputs for improved accuracy and reduced errors. For example, an LLM can refine a Python function for factorial calculation, correcting initial responses to handle negative or non-integer inputs more robustly. These diverse prompting techniques are crucial for maximizing the potential of LLMs, allowing us to elicit more useful and reliable responses. Experiment with these methods to enhance your AI outputs and unlock new possibilities in your applications. Thank you for watching.
Welcome to Prompt Engineering, from beginner to advanced, a comprehensive training program designed to unlock the full potential of large language models. This program will guide you through LLM basics, various prompt types, and practical exercises, using engaging visuals like diagrams and charts. Our training overview covers 6 key modules, starting with beginner foundations and progressing to advanced prompt engineering. We'll explore prompt categories, intermediate and advanced techniques, domain-specific prompting, and conclude with a final assessment. Prompt engineering is crucial because it unlocks the full potential of LLMs, significantly improving output quality and consistency. It also plays a vital role in reducing hallucinations and errors, enabling complex problem solving, and is critical for AI-powered business applications. Consider the example of chain-of-thought prompting, where a language model processes a prompt through a series of reasoning steps. This method, along with self-consistency, helps aggregate final answers by sampling diverse reasoning paths, as shown in the example of calculating daily earnings. Now, let's delve into the fundamental building blocks, LLM basics. Large language models are neural networks trained on vast text data to understand and generate human-like text. Tokenization is the process where text is broken down into smaller units, or tokens, for processing by the model. Key parameters like temperature control randomness, while top P limits token selection to a cumulative probability. System prompts set the model's overall behavior, whereas user prompts provide specific task instructions. The context window defines the limited number of tokens an LLM can consider at once, varying by model. A central diagram illustrates the prompt engineering process, showing a user inputting prompts, the LLM processing them, and producing an output. Next, let's break down the anatomy of a high-quality prompt. A high-quality prompt consists of clear instructions, defining exactly what the model needs to do. It also includes context, providing relevant background information for the task. Constraints are essential, setting boundaries and limitations for the model's response. Finally, an output pattern specifies the desired format for the model's generated response. An example prompt for generating a marketing email demonstrates these components in action, specifying instruction, context, constraints, and output pattern. Let's explore some basic prompt types. These include direct instruction, question answering, creative generation, analysis, transformation, and code generation. For instance, a direct instruction prompt might ask the model to summarize the following text. A question answering prompt, like "Where are penguins found?" expects a factual response. Creative generation prompts encourage the model to produce original content, such as a poem or story. Analysis prompts require the model to interpret data or text, while transformation prompts involve reformatting content. Code generation prompts instruct the model to write programming code based on given specifications. To build fundamental skills, we have beginner exercises. These exercises include improving vague prompts, adding context and constraints, and experimenting with temperature settings. Further exercises involve transforming content and practicing format control, all designed to strengthen your prompting abilities. Finally, let's look at an overview of prompt categories. These categories include direct instruction, role prompts, and various shot prompts like zero shot, one shot, and few shot. We also cover advanced techniques such as chain of thought, React, RAG, and safety prompts. Diagrams illustrate different prompting techniques, including input-output, chain of thought, self-consistency with COT, and tree of thoughts. This comprehensive program will equip you with the skills to master prompt engineering and effectively interact with LLMs.
Your career knows no borders. Discover a world of possibilities. And take the next step in your professional journey with Jobsonn. Your future, elevated.